Welcome. This video is intended for specifically calculus students that are entering calculus, maybe feeling like they need to review some trig. This is certainly not meant to replace a semester trig course by any means, but maybe just getting you started with some of the basics that you need to know. So first things first is when we talk about triangles and side ratios, we're really just talking about two triangles. Forgive my drawings from here on out. We're talking about a 30, 60, 90 right triangle, or we could stand that triangle up, and this might be a little extreme, but as you see right here, and now my 60-degree angle is down here and the 30-degree angle is up there. It's really the same triangle, just one is laying down and one is standing up. And the other triangle that we will study is the right isosceles triangle, which actually looks the same as my other one, where it's a 45, 45, 90 right triangle. And what we're going to do is we're going to put sides or side ratios onto these as if we are in a unit circle. And if we are in a unit circle, our hypotenuse is a 1, or our radius of that circle is a 1, and I will do all of my triangles accordingly. If you have learned this with a radius or hypotenuse of 2, that is completely fine. You could just double all of your sides. So, for example, opposite my 30-degree angle, so the angle, if you draw opposite of that, that's the side that does not touch that angle, that side is always 1/2. So even on the standing up triangle, the opposite side from that 30-degree angle is 1/2. And then opposite the 60-degree angle is always rad 3 over 2, or square root of 3 over 2. And those are pairs that will always go together, so yes, that is something that you can know. On the 45, 45, 90 right triangle, you could use Pythagorean theorem to show this because both sides are the same, and the sum of those squares should be 1. So it's either rad 2 over 2, or you could have seen this in the past as 1 over square root of 2. And these will be the side ratios that we will use from here on out, just so you can kind of get used to seeing that. And now anytime I reference any amount of pi over 3 type of triangle, we're really going to look at that denominator. So in radians, pi over 3 translates to some 60-degree triangle, and pi over 6 translates into some 30-degree triangle, and we'll just try to figure out what quadrant that would belong in. And then some pi over 4 will be a 45-degree triangle, and that's how we'll know which of the three triangles we have. Okay, so speaking of this unit circle idea, let's talk about what this will look like. So for example, if I ask you to find the sine value at 2 pi over 3, what I'm looking for is the triangle that will represent this 2 pi over 3 angle. So if I write what all of these boundaries are in terms of radians, I start at 0, I rotate up into the first quadrant until I get to 90 degrees, which is pi over 2, rotate over to create a straight line, that's pi, or 180 degrees. Continue rotating. I'm now on the boundary between the third and fourth quadrants, or the negative y-axis. That is the 3 pi over 2, and then all the way around would get 1 complete revolution, or 2 pi units. So 2 pi over 3, I have to figure out where that's going to be. And I'll get these out of my way here. So 2 pi over 3, I think about it in terms of thirds, and my pi, or 1 pi, is 3/3. And so 2 pi over 3 is 1/3 shy of 3/3, and so it's right here in that second quadrant. And then since I know it's a third, I know that's the 60-degree angle, and I know from the discussion that we just had here, if my hypotenuse is a 1, opposite my 60 is always rad 3 over 2, and opposite the other angle, which is the 30 degrees, would be the half, or the other leg of that right triangle would be 1/2. Well, the other thing that I need to focus on is depending on the quadrant that you're in, your side lengths will be either negative or positive. So because I'm going left, right, I'm plotting this point up here in the second quadrant, because I'm going left, my x value would be negative, and because I'm going up, my y value would be positive. Now I can think of sine of this angle in two ways. I can think of it as opposite over hypotenuse, so it'd be radical 3 over 2 over 1. Or, since my hypotenuse is a 1, I'm on a unit circle, and therefore it's just the y value, because I would always be dividing by 1 for a hypotenuse. Okay, let's try another example here. So now we will go to the example of cosine of 7 pi over 6. Now because I see the 7 pi over 6, I know that this is going to be some 30-degree triangle. I just have to figure out where. So 7 pi over 6, again, if I label all of these, the more you label them, the better you get. So this is 6/6, or 1 whole pi. And so 7/6 is 1/6 past the pi, or 1/6 past 6/6. So 7 pi over 6 would be right here in the third quadrant. And since it's a pi over 6, I know that my reference angle in there is a 30-degree angle. And I label my triangle accordingly. So opposite my 30 degrees, so this side is a 1/2. Opposite of my 60 degrees is a square root of 3 over 2, with the hypotenuse being a 1. And then what I need to make sure that I do, of course, is go through and make sure that I put my positives and negatives. So based on my quadrant that my point is in, going left, so my x value is negative, and I'm going down, so my y value is negative. And since I want the cosine value of this angle, here's my reference angle in that triangle, I want the x value, which is negative rad 3 over 2. The reason I can say it's just the x value is because my hypotenuse is a 1. If I think about it, this angle I could use cosine is the ratio of adjacent, which is the square root of 3 over 2, over hypotenuse, and my hypotenuse will always be a 1. And so it works out to just be the x value. Let's try one more. Let's try sine of 5 pi over 4. So I'll draw it first, just like normal. I'll label all my boundaries. And of course I could keep going around, but I think 0 to 2 pi is typically the domain that we find things in and solve for. So just going around the unit circle one time. So 5 pi over 4. So again, if I want to think of my pi in terms of force, that's 4 force. And so I can think of 5 force as being 1/4 more than that. And so 1/4 more than that is 45 degrees, because remember the force are the 45 degrees. So opposite my 45 degrees, again I have my hypotenuse of 1, is a rad 2 over 2. And the nice thing about the 45, 45, 90 right triangles, you're not going to get the legs wrong, hopefully, because they're both the same. So there is no placement, per se, of each leg, because, again, it's isosceles, so those legs are, in fact, the same. And now don't forget to put your positives and negatives on these based on the quadrant that you're in. So because I'm in quadrant 3 down here, again, I go left, so that's negative, and I go down, so that is negative. Now, the sine of this angle right here, I could look at the reference angle and use opposite over hypotenuse, but since the hypotenuse is 1, I don't need to say that. I can just say sine is the y value, which is negative square root of 2 over 2. I think one more we'll have time for, so I'll do another real quick one here. Last one of these, we'll do cosine of 5 pi over 6. And so again, I'll draw it. 0 pi over 2, because it's 90 degrees, pi, 3 pi over 2, and 2 pi. And so what I'm going to see, and I'm actually going to move this, cosine of 5 pi over 6, so I can have a little bit more room. So cosine of 5 pi over 6, if I think of pi again in terms of one whole, pi is 6, just so I can kind of compare the denominators or compare these fractions, I'm looking for 5 pi over 6. Well, that is 1 pi over 6 short of getting to that whole pi, or 30-degree reference angle short of getting all the way to pi. And then I label it accordingly. Hypotenuse of 1, opposite my 30 is a half, other leg is square root of 3 over 2, and then I of course put on my positives and negatives based on my quadrant that I'm in. Since my point is in quadrant 2, I'm going left, so the x value is negative, but I'm going up, so my y value stays positive. And now I look back at what I'm trying to find about this. Well, I'm trying to find the cosine of 5 pi over 6. That will turn out to be the x value, or in other words, the adjacent over hypotenuse. But again, I don't need to necessarily say over 1, so I can just say that this is the x value, negative square root of 3 over 2. And what I'd like you to pay careful attention to is I got an answer of negative square root of 3 over 2 twice, and both times I was doing cosine. So cosine of 7 pi over 6 is the negative square root of 3 over 2, and cosine of 5 pi over 6 is negative square root of 3 over 2. So when we're going to solve, and I'm looking for where is the cosine, negative square root of 3 over 2. If this is my question now, I now know that I have two angles which make that happen. The 5 pi over 6, which I just found, and the 7 pi over 6 that I found earlier. There are two triangles that both have an x value of negative, because here was a triangle in the previous one, x value is negative, and it has a 30-degree reference angle. And here's the triangle in the one we just did, where again, the x value is negative. I'm in the second quadrant, and the reference angle is 30 degrees. So I have the 5 pi over 6 and 7 pi over 6 triangles that both get me the same cosine ratio. So let's talk about that solving. Go to some angles, and let's start with something like sine of, I'm just going to number this number 1, sine of theta equals rad 2 over 2. So what I'm looking for is I'm looking for the angles that have a sine ratio of rad 2 over 2. So now I'm giving you the ratio and I'm looking for the angle. So I still think of this the same way that I do in the other ones. I do a quick sketch here and I label everything accordingly. And I try to figure out what this is going to look like. Well, if I have a y value of rad 2 over 2, it's positive, so that means it could have been here, or I also have a y value of rad 2 over 2 in the second quadrant, because that's also positive. So I have the same reference angle in both triangles, so it's the same triangle, just in different quadrants. So I need to figure out what that angle is. Well, you go back to your opposites. Opposite of square root of 2 over 2 is always a 45-degree angle. So these are both 45-degree angles. In other words, those are my pi over 4 reference triangles. Well, this one is pi over 4 because I just rotate straight up to it. And the other one, I go around to it. Right? So I'm starting from the positive x-axis and getting to this point right here. So I rotate around. Well, if this is 4 pi over 4 for one whole pi, I'm 1/4 short of getting to a whole pi. That makes 3 pi over 4. So I have two triangles that both, if I did the sine of pi over 4, I would get square root of 2 over 2. And if I figured out the sine of 3 pi over 4, I would also get positive square root of 2 over 2. So when I'm solving backwards or solving for that angle, I know I should be looking for those two triangles or the two angles that give me that positive sine ratio. Okay, next we will look at tangent. We haven't talked a lot about tangent yet. Tangent of theta equals -1. Okay, so tangent of theta equals -1. Tangent is sine of theta over cosine theta. And so what I'm trying to think of is I need a triangle where if I divide the y by the x, or the opposite and the adjacent, and their ratio turns out to be a 1 or a -1, I know those legs had to be the same length. So if I think about this, I know that I'm looking for a triangle whose x and y values are the same. But I have to figure out what quadrant that goes in. So I'm not sure if you're familiar with All Students Take Calc. Most people remember what it is and don't necessarily remember what it stands for, or don't necessarily know how to use it. This is for all. So all of my trig functions are positive in the first quadrant. Quadrant 2, sine of theta is positive and cosecant of theta is positive. It's reciprocal. In quadrant 3, only tangent of theta and its reciprocal cotangent of theta are positive. And in quadrant 4, cosine of theta and secant of theta, its reciprocal, are positive. So this tells me who is positive in which quadrant, or which trig function is positive where. So I have tangent being negative. So tangent's positive in 1 and 3, so I know my triangle must exist in 2 and 4. And now I'm just trying to figure out what type of triangle is it. Well, again, we said if this ratio was the same, that's the only way they're going to divide to be a 1 or a -1. And now let's see why they divide to be a -1. Well, my x value is positive in the fourth quadrant, but y value is negative. That would divide to be a negative number. And over here, my x value is negative, but the y value is positive. And so that would divide to be a negative number. And each of these triangles are actually the 45, 45, 90, who has the side ratios of square root of 2 over 2. And so I know it's a 45, 45, 90 right triangle. And so what I now need, and I'll put that in there, 45, is to convert that to pi. And so 45, 45, 90 was the pi over 4 triangle. And so I'm saying that I need to get there though. So how many pi over 4s get me there? Well, the negative x-axis is pi. So I'm 1 pi over 4, or 45 degrees short of getting to pi, which is 4/4. So that angle should be 3 pi over 4. And then I have to go all the way around, almost, and I'm 45 degrees short of going all the way around. All the way around we talked about being 2 pi, and so pi over 4 short of going all the way around. Well, 2 pi is 8/4, and so I'm 1 pi over 4 short, because see my reference angle was the 1 pi over 4, so I'm 1 pi over 4 short of going all the way around. That is 7 pi over 4. I could have just said negative pi over 4 as well, because that meant start at the positive x-axis and rotate down. But we typically talk about our domain solving between 0 and 2 pi, so that way I have to give the positive value. Just make sure you check your domain before you start. Okay, let's do one more real quick here. Let's do tangent of theta equals, we'll do positive this time, 1 over square root of 3. And so in this case, what I like to think of is tangent comes from a ratio of sides of a right triangle. And tangent is positive, like we just talked about, in the first and in the third. I'm not going to put too much on here because, as you can see, my last graph got pretty busy. So I'll try to keep this one pretty clean. So 1 over rad 3. Well, tangent is also opposite over adjacent, or you can think of it as sine over cosine, sine of theta over cosine theta. So you could think of it as if this is my theta right here, opposite would be 1, and adjacent would be square root of 3. I could think of it like that. But then if I do Pythagorean theorem, I'm going to get that my hypotenuse is 2. We haven't talked about a hypotenuse of 2. All of our hypotenuse have been 1. So I can just think of it as dividing all three sides by 2 because it's a scalar multiple of that same triangle. So now I have a hypotenuse of 1, and I can see my 1/2, and I can see my square root of 3 over 2. So opposite of 1/2 has to be what kind of angle? Well, it has to be the 30-degree angle. So theta is the pi over 6, which is my 30-degree angle in the first quadrant. And then I have to get to this other one. Well, it's also a pi over 6, but I have to think of it in terms of what quadrant it's in or how I get there. Well, I have to go past pi to get there. So pi in terms of 6 is 6/6. So I'm going 1 pi over 6 past that, or 7/6. Okay, so let's go on to solving using some identities to see how we do with that problem will look like here. So solving with these identities, so let's see, I'll do a couple of these. So sine of 2x equals sine of x. And you should have a list, or you can ask your instructor for what are the trig identities that you should know, but certainly the double angle identities you're going to need to know, the Pythagorean identities, and then certainly your reciprocal and basic definitions of trig. Okay, so one basic idea of trig is that when you have more than one trig function that you see there, so I see a sine of 2x and a sine of x. If it was just sine of 2x and then a constant value like a half, I don't necessarily need to do anything with the double angle. But if I have more than one trig function here, sine of 2x and sine of x, I need to make sure that I can somehow make sure these are in the same angle and in the same trig function. So they're not the same angle because certainly one is a double angle and one is a single angle. So one is sine of 2x while the other one is just sine of x. So I'm going to use the identity for sine of 2x, which is 2 sine x cosine x, and it equals sine x. Okay, and here's where some people try to do things like, oh, I'm going to divide both sides. No, when we do that, we lose some answers. If you divide both sides by a variable, you potentially lose answers that you might need. So I'm not going to divide by anything. If your thought is, I want to divide by a function, then you should probably be factoring that function out instead. So what I'm going to do is subtract the sine of x from both sides so that everything is on the left side, for example, of my equation. And now I can see that I can factor out the sine of x. Don't forget the 1 as the placeholder. Now this video is sort of assuming that your algebraic manipulation is okay, just that we need help with the trig. So I'm assuming that the zero product property, which says, you know, when you have two factors that multiply to be 0, one or both have to be 0. So I'm assuming this part doesn't need all that much explanation. And so where is the sine of x 0? Well, that's got to be one of the quadrantal angles. So sine of x I want to think of as a y value, and where it's 0 is it's not leaving this x-axis. So that's an angle of 0 and an angle of pi. And again, we're not going to keep going, but it could be 2 pi, 3 pi, 4 pi, 5 pi, etc., just based on the domain. But again, we're sticking between the domain 0 to 2 pi, and I'm not going to include both 0 and 2 pi since they're the same place. And then this equation I need to solve, where is cosine of x equal to a half? So I need to think about what that triangle looks like. And again, there's going to be 2 of them because there's 2 places where the x value is positive. X value is positive in the first quadrant. X value, that's supposed to look the same. X value is positive also in the fourth quadrant. So I'll try to draw that a little bit better. Not too much. So both of these have an x value of a half, which means their y values are square root of 3 over 2. So even though it doesn't look like it, that angle in that triangle is 60 degrees, right? Because opposite your 60 is your rad 3 over 2. So I know that that has an x value of pi over 3. And if I could say it, I would have just said negative pi over 3, but certainly let's go all the way around that way. I'm 1 pi over 3 short of getting all the way over to 2 pi. 2 pi is 6/3. So I'm 1 pi over 3 short of that, so I'm at 5 pi over 3. So I do have 4 answers, 0 and pi, pi over 3, and 5 pi over 3. So let's try another one, and this one we'll use the Pythagorean. So this one will look like 1 minus 2 cosine squared x equals sine of x. And so what I can see here is I have a cosine squared function and a sine function. Those certainly aren't going to combine well together, so what I'm going to need to do is use my Pythagorean identity, which stated sine squared x plus cosine squared x is 1. And I need to think about how can I rewrite that? Well, I'm going to replace cosine squared x with what it is in terms of sine squared x. So it is 1 minus sine squared x. And now I have this equation all at least in the same trig function. So I'll distribute my negative 2. And here's where I get my quadratic. Okay, now since this is quadratic, I want to definitely set this equal to 0 and put it in descending order. So I'll put my quadratic term first, minus the sine of x, and then 1 minus 2 gets me minus 1. This is factorable, so I'll go ahead and factor it with 2 sine x, sine x. So the quantity, and they multiply to be 1, so they've got to be a 1 and a 1. I need my middle term to add up to negative 1, so it'll be negative 2, positive 1. Okay, so now I have my zero product property again. So this one is going to give me 2 sine x plus 1 is 0. So sine of x equals negative a half. I'll figure out where that is. And this one, sine x minus 1 is 0. So sine of x will be 1. Okay, so where is the sine of x? Negative 1/2. Well, sine is negative in quadrants 3 and 4. And if I think about this triangle, and the more you do, the faster you get at this, opposite my 1/2 side is always a 30-degree angle, or a pi over 6. And again, thinking about it in terms of pi or 2 pi, so I'm 1/6 past the pi, or 1/6 pi past the pi really, so 7 pi over 6. And then I'm 1/6 pi short of going all the way around, which is 12/6, so this would be 11/6. And then over here, for sine x equals 1, I'm looking for where is the y value 1. Well, that's the point straight up. There's not necessarily a triangle that's going to represent that, but that's where my y value is 1 straight up. That's an angle of pi over 2. So I have 3 answers. And of course, anytime when you're solving, I definitely recommend that you check. So I would put these 3 into the very original, certainly one at a time, but let's say you start with pi over 2, put that into your original, substitute that in for x, and see if what you get is a true statement. You know, something like 5 equals 5, then you know that that pi over 2 works. Then check your 7 pi over 6, and then check your 11 pi over 6, just to make sure that all of your solutions do in fact work.